To truly understand the dense tropical forest, we have to abandon our human perspective of the world. We are ground-dwelling creatures, so we tend to view forests as collections of trees rooted in the soil. But in the tropics, specifically in ecosystems like the Amazon basin, which covers approximately 5.5 million square kilometers, or the Congo basin in Africa, the soil is merely a foundation for a vertical city so complex that scientists are still discovering new species in its upper reaches every single day. This verticality is defined by distinct layers, each with its own climate, its own inhabitants, and its own rules of survival. The forest floor, which is the first layer, is a world of complete and utter darkness. If you have ever walked through a temperate forest, you are used to seeing shrubs and flowers covering the ground. In a dense tropical rainforest, you will see almost nothing but dirt, roots, and decaying matter. Why? Because less than 2% of the sunlight actually filters down to this level. The canopy above acts as a massive solar panel, absorbing all the energy. This creates an environment that is humid, still, and dark. At this level, you will find the decomposers, the cleanup crew of the forest. Termites, fungi, and bacteria work overtime here. In a normal climate, a fallen leaf might take a year to decompose. Here, it vanishes in about 6 weeks. The heat and moisture accelerate decay, recycling nutrients as fast as possible to feed the giant tree above. This is also the realm of the largest predators. This is where the jaguar in South America prowls, its spotted coat acting as perfect camouflage in the dappled dimness. They follow the waterways and the trails cut by tapirs and peccaries. But contrary to popular belief, you won't find dense thickets of plants here. It is surprisingly open, allowing for easy movement if you can handle the gloom. It is also the only place where the massive buttress roots of the emergent trees can be seen. These roots extend like giant wooden wings from the base of the trunk, sometimes 10 feet tall, stabilizing the giant in the shallow tropical soil. You see, tropical soil is actually surprisingly poor. It is ancient, leached of nutrients by millions of years of rain. The forest doesn't grow from the soil exists merely as an anchor. The nutrients are all stored in the living wood, not in the ground. This is a critical fact that explains why deforestation is so catastrophic. When you cut down the trees, you remove the nutrient bank. The soil left behind is useless red clay that bakes in the sun, incapable of supporting life. So as we stand on the forest floor, looking up, we see the trunks rising like the columns of a natural cathedral. They disappear into the gloom above, leading us to the next layer, the understory. But before we ascend, remember that this dark, dank floor is the engine of decay and rebirth. It is home to the poisonous dart frog, which carries its tadpoles on its back up into the trees to deposit them in pools of water, collected in bromeliads high above. The floor and the sky are intrinsically linked. The survival of the forest depends on the cycle of death on the floor, feeding the life in the heights. This is the stage where the great forest elephants of Central Africa roam, using their tusks to dig for salt and minerals, creating clearings that turn into watering holes for countless other species. The forest floor is not dead. It is waiting. It is patient. Seeds that fall here lie dormant, sometimes for years, waiting for a gap to appear above. When one of the ancient giants falls, either to old age or a storm, a sudden shaft of light hits the ground. In that moment, the dormant seeds erupt. It is a race to fill the gap, to reach the sky before the canopy closes again. This brutal competition for light defines everything about the rainforest. And it is on this dark floor that we find our first major call to action, understanding that this darkness is not emptiness, but potential. If we continue to clear the forest, we stop the cycle permanently. There is no waiting, no dormant period. There is only desertification. We have to be the voice for the species that live in this perpetual night. Rising above the dark forest floor, we enter the understory. This is the second layer of the dense tropical forest, and it is best described as the waiting room of the jungle. The understory is a layer of shade and humidity consisting of the trunks of the canopy trees, smaller trees, shrubs, and juvenile plants waiting for their chance to grow. While the forest floor is dark and relatively open, the understory is often a tangled mess of vines and climbing plants. This is where you will find the lianas, woody vines that root in the soil but climb up into the canopy. They look like giant wooden snakes hanging from the trees. For decades, ecologists thought these vines were parasites, stealing light and nutrients from the trees. However, recent research reveals a more complex truth. These lianas actually connect the trees, acting as a network that holds the forest together during storms. They also serve as a highway for arboreal animals. Ants, monkeys, and sloths use these vines to move from tree to tree without ever descending to the dangerous forest floor. The understory is a world of adaptation. Because light is limited, the plants here have developed massive leaves. We are talking about leaves that can be 4 feet wide, like those of the elephant ear plant. They are designed with a large surface area to capture every possible photon of light that filters through the canopy. This layer is also the realm of the big cats when they do decide to climb, and it is the primary hunting ground for snakes. The emerald tree boa and the green tree python, depending on which continent you are on, spend their entire lives coiled on branches in this layer. Their perfect camouflage, making them invisible to the birds and small mammals passing by. The humidity here is nearly 100%. It rarely rains on the understory directly because the canopy catches it, but the air is so thick with moisture that you feel like you are breathing through a warm, wet sponge. This humidity allows for a fascinating group of animals, amphibians. Poison dart frogs are abundant here. Their bright colors a warning to predators about the toxicity of their skin. Interestingly, these frogs get their poison from the ants and beetles they eat on the understory floor. In captivity, when fed a different diet, they lose their toxicity. This proves that the poison isn't theirs, it is a product of the forest's complex food web. The understory is also where you find the most inventive nesters. The oropendola, a bird found in Central and South America, weaves hanging basket nests that dangle from the ends of branches. They do this specifically to keep their eggs safe from climbing monkeys and snakes. The ends of branches are too thin for most predators to reach. The understory is also the layer of sound. If you stand quietly in this zone, you will hear the rustle of leafcutter ants below you carrying pieces of leaves back to their underground fungus farms. These ants are perhaps the most important engineers of the forest. They don't eat the leaves, they use them to cultivate a specific fungus that serves as their only food source. In this process, they aerate the soil and prune the vegetation, keeping the forest healthy. The understory acts as a filter, a place of transition. It protects the floor from the sun and catches the debris falling from the canopy. It is a chaotic, vertical maze of stems and trunks. For a human, moving through the understory is nearly impossible without a machete, but for the wildlife it is the main thoroughfare. The okapi, the only living relative of the giraffe, lives in the dense understory of the Congo. It uses its long blue tongue to grab leaves and also to clean its eyes and ears. The stripes on its hindquarters, reminiscent of a zebra, break up its outline in the dappled light of the understory, helping it disappear. This layer is the lungs of the forest, the interface between the earth and the sky. As we look up from here, we see the ceiling of the world, the canopy. And that is where we are heading next. But remember, the health of the canopy depends entirely on the structural integrity of this middle layer. If we lose the understory, the canopy becomes exposed, dries out, and dies. If the forest floor is the foundation and the understory is the walls, then the canopy is the roof of the cathedral. And it is, without any doubt, the most vibrant, diverse, and critical layer of the dense tropical forest. The canopy is located approximately 30 to 45 meters above the ground. It is formed by the interlocking branches and leaves of the mature rainforest trees. This is not a solid sheet of green, but rather a mosaic of leaves and light. It is here that the majority of the forest photosynthesis happens, generating the oxygen we breathe. It is estimated that 90% of the organisms in the rainforest live exclusively in this layer. For centuries, humans knew almost nothing about it. We were ground dwellers, and the canopy was a lost world above our heads. It wasn't until the 1980s, when scientists started using ropes and cranes to access the canopy, that we realized how wrong we were. We discovered that the canopy has its own soil. Yes, you heard that right. Decomposing leaves and organic matter collect in the crooks of branches, forming a layer of airborne soil. In this suspended earth, insects, worms, and even crabs live their entire lives without ever touching the ground. Epiphytes or air plants dominate this layer. Orchids, bromeliads, and ferns grow directly on the bark of the trees. They are not parasites, they are just looking for a perch in the sun. The bromeliads, which are related to pineapples, form a central cup that collects rainwater. These tiny pools, called phytotomata, are entire ecosystems unto themselves. They contain mosquito larvae, frogs, and even small crabs. The canopy is a world of fruit and flowers. Because there is so much light, the trees here produce the vast majority of the forest fruit. This makes it the grocery store for the jungle. This is where the monkeys live. From the howler monkeys, whose calls can be heard 3 miles away, to the spider monkeys using their prehensile tails as a fifth limb. The primates are the gardeners of the forest. They eat the fruit and disperse the seeds far and wide in their droppings. The canopy is also home to the toucan with its oversized bill. That bill isn't just for show, it is a highly efficient tool for reaching fruit on thin branches and for regulating body temperature by radiating heat. The birds of the canopy are some of the most colorful on Earth. The scarlet macaw, with its red, yellow, and blue plumage, flies above the canopy but feeds within it. The sunlight hitting these birds is a spectacle of pure color. But life in the canopy is not easy. It is windy, hot, and exposed. The leaves here are thick and waxy to prevent water loss, unlike the soft, large leaves of the understory. The animals here are specialized for acrobatics. The sloth, one of the slowest animals on Earth, spends its entire life hanging upside down in the canopy. Algae grows on its fur, providing camouflage and a small snack for the sloth when it grooms itself. The sloth descends to the ground only once a week to defecate, a behavior that scientists still can't fully explain and which makes it extremely vulnerable to predators. The canopy is also where we see the most incredible symbiotic relationships. In the video game of evolution, the canopy is the final boss level. The trees themselves communicate through underground fungal networks, but in the canopy, they compete directly for light. They have evolved to stagger their flowering times to attract specific pollinators. Orchids mimic the appearance and scent of female bees to trick male bees into trying to mate with the flower, thus pollinating it. The canopy is the engine of the water cycle. Through a process called transpiration, the trees release water vapor into the atmosphere, which forms clouds that produce rain. This means the rainforest actually creates its own weather. About half of the precipitation that falls in the Amazon is generated by the forest itself. This is a closed-loop system. Cut down the trees, and you break the pump. Without the canopy transpiring, the clouds don't form and the rain stops. The implications of this for global agriculture are staggering. The water cycle that waters the farms in Brazil, Argentina, and even the United States is partly driven by the Amazonian canopy. If we lose this layer, we don't just lose monkeys and birds, we lose our food security. Towering above the canopy, standing like lonely sentinels against the sky, is the fourth and final layer, the emergent layer. These are the giants of the forest. These trees, such as the kapok or the Brazil nut tree, rise above the canopy roof, reaching heights of up to 70 meters or more. They are the skyscrapers of the natural world. To reach this height, these trees have had to evolve incredible strength and resilience. Their trunks are often 2 to 3 meters in diameter, and their roots, which we saw on the forest floor, are massive buttresses that spread out to hold them upright against the wind. Because they stand alone, Exposed to the full force of the sun, wind, and rain, the emergent trees have a different physiology than their sheltered neighbors below. Their leaves are smaller and thicker, coated in a heavy wax to prevent desiccation. They are also the oldest organisms in the forest, some living for over 1,000 years. This layer is the observation deck of the jungle. It is the least populated layer because it is so exposed. The conditions are harsh, the temperature can fluctuate wildly, and the wind can be strong. Only the most specialized species live here. The harpy eagle, one of the largest and most powerful eagles in the world, rules this layer. It is the apex predator of the rainforest canopy. With talons as large as the claws of a grizzly bear, the harpy eagle hunts sloths and monkeys. It doesn't just fly through the canopy. It flies above it, diving down with incredible speed and precision. Their legs are so thick that a monkey's bite cannot penetrate them. The presence of the harpy eagle indicates a healthy, intact forest. They require vast territories to hunt, and if the forest is fragmented, they cannot survive. Also found in the emergent layer are troops of howler monkeys who climb up here in the early morning to greet the sun. Their guttural roars, amplified by a specialized hyoid bone in their throat, resonate through the forest for miles, serving as a territorial claim to other troops. Birds like the scarlet macaw fly through the layer, their bright plumage contrasting against the blue sky. Bats also patrol this zone at night, feeding on the nectar of the large flowers that bloom only at the top of these trees. The emergent trees are crucial for the reproduction of the forest because they are exposed to the wind. Many of them rely on wind pollination rather than insects. They release their seeds into the air, hoping they will land in a clearing where they can grow. The Brazil nut tree is a perfect example. Its large, hard pods containing the nuts fall from the emergent layer to the forest floor. They are so hard that the only animal capable of opening them is the agouti, a large rodent with teeth sharp enough to gnaw through the pod. The agouti buries some of the nuts for later, and the ones it forgets grow into new trees. This intricate relationship shows how the very top of the forest is connected to the very bottom. The emergent layer also plays a critical role in the global climate. These tall trees act as carbon sinks, storing massive amounts of carbon in their wood. A single emergent tree can hold as much carbon as an entire acre of savanna. They are the front line in the fight against climate change. But because they are the tallest, they are also the most vulnerable to lightning strikes and storms. When a giant falls, it creates a gap that allows light to flood the forest floor, resetting the cycle of growth. As standing at the base of an emergent tree, looking up until your neck hurts, you realize the sheer scale of life. You are looking at a living organism that was a seedling before your great-grandparents were born. It has survived droughts, floods, and fires. It has seen centuries pass. This perspective is humbling. It reminds us that we are visitors here. We are the newcomers. These trees have been managing the planet's atmosphere for millennia. Yet, in the last 50 years, we have cut down more of these giants than in the previous 5 centuries combined. The loss of an emergent tree is not just the loss of a tree, it is the collapse of an ecosystem that took 1,000 years to build. The harpy eagle that nested there must move on. The orchids that grew on its branches die. The carbon it stored is released. This is the reality of deforestation. Now that we have journeyed from the dark, decaying forest floor up to the sun-blasted emergent layer, we must address the existential threat facing these layered cathedrals of greenery. We have discussed the intricate web of life, but that web is being torn apart at an unprecedented rate. Tropical rainforests once covered about 14% of the Earth's land surface. Today, they cover less than 6%. If it were a country, the amount of forest we lose annually would be the size of Greece. The primary driver of this destruction is agriculture. Not subsistence farming, but industrial agriculture. The global demand for beef, soy, and palm oil is the engine of deforestation. In the Amazon, huge tracts of land are burned and cleared for cattle ranching. The grass planted for cattle only thrives for a few years because the soil is so poor. After that, the ranchers move on, clearing more forest, leaving behind a degraded, barren landscape. In Southeast Asia, rainforests are cleared to plant oil palm plantations. These plantations are biological deserts. They support almost none of the native wildlife. The orangutan, whose name means person of the forest, is critically endangered precisely because its home is being converted into palm oil, which ends up in half the packaged products in your local supermarket, from shampoo to cookies. In West Africa, the rainforests are being cleared for cocoa and rubber. The chocolate you eat likely comes from land that was once primary rainforest. But the destruction isn't just about land use. It is about climate change. As the planet warms, the rainforests are drying out. The dense, layered greenery that once trapped moisture is becoming tinder. In 2019, the world watched in horror as the Amazon burned. But those fires were not natural. They were set by humans to clear land. However, the dry conditions caused those fires to spread out of control, burning vast areas of forest that were never intended to be cleared. This creates a feedback loop. Fewer trees mean less rain. Less rain means a higher risk of fire. More fire means more carbon emissions. It is a death spiral. The loss of biodiversity is heartbreaking. We are losing species before we even discover them. It is estimated that we lose 137 species of plants, animals, and insects every single day due to rainforest destruction. That is a rate of extinction not seen since the dinosaurs disappeared 65 million years ago. The difference is that the dinosaur extinction was caused by an asteroid. This one is caused by us. The indigenous tribes that have lived in these forests for thousands of years are also under threat. They are the guardians of the forest. Studies show that lands managed by indigenous peoples have lower rates of deforestation than national parks. They know the forest better than any scientist. They have names for plants we haven't classified. Their languages hold the secrets to the medicinal properties of the bark and leaves. When they are displaced or killed, that knowledge dies with them. But there is hope. There is always hope. We are seeing a global awakening. Reforestation projects are popping up all over the world. In Costa Rica, a country that lost most of its forest, they have managed to double their forest cover through smart policy and ecotourism. Countries are committing to planting billions of trees. Technology is helping us monitor deforestation in real time, allowing authorities to stop illegal loggers before they do too much damage. As consumers, we have power. We can choose products that use sustainable palm oil. We can reduce our meat consumption. We can support companies that commit to zero deforestation supply chains. We can donate to organizations that protect rainforest land. The YouTube algorithm can be a force for good. If this video reaches enough people, if it educates and inspires, we can shift the conversation. This is not just about saving a pretty place. It is about saving the planet's lungs. It is about saving the water cycle that grows our food. It is about saving the library of species that holds the cure for diseases. The dense tropical forest with its layered greenery is not a resource to be exploited. It is a relative to be protected. If your heart is beating as fast as mine right now, you cannot just close this tab and forget about it. The forest needs you. Right now, governments are making decisions about land use. Corporations are deciding where to source their materials. We have to be louder than the chainsaws. We have to be more persistent than the fires. Here's what I need you to do immediately. First, smash that like button. Not for me, but for the forest. Let the algorithm know that people care about nature. Second, share this video. Send it to one friend. Text it to your family. Post it on your story. Start a conversation. Third, subscribe and hit the notification bell so you can join us on this journey to explore and protect our planet. And finally, I have placed links in the description below. Links to vetted organizations that are on the ground, protecting the rainforest, planting trees, and fighting for indigenous rights. Go click those links. Even $1 makes a difference. If you can't, Donate. Share the links. Be the voice that the trees don't have. The future of the emergent layer, the canopy, the understory, and the forest floor rests entirely in our hands. Will you stand with the forest? I'll see you in the next video, where we will dive deeper into the animals that call this place home. Until then, stay curious and stay fierce.